Welcome back to Suchiverse, the place where learning gets simpler and smarter. Today we are going to learn about another concept in machine learning, which is logistic regression. Logistic regression is a supervised machine learning algorithm used for classification tasks. In linear regression, we predict continuous values, but logistic regression is used for classification tasks. In today's video, we will be discussing about binary classification, which is nothing but either 0 or 1, yes or no, pass or fail, whether the email or message is spam or not spam. These kind of tasks are known as binary classification tasks. Let's say we have this data. If the person is studying for 1 hour, they are going to fail in the exam. Similarly, if the person is studying for 2 hours, they are going to fail. For 3 hours also, they are going to fail in the exam. But if the person is studying for 4 hours, then they are going to pass in the exam. Similarly, for 5 hours, they are going to pass the exam. Now let's get into math. For linear regression, we know it is a straight line. So which will be like infinity to minus infinity. And we also know the equation of the straight line, which is nothing but z equal to something like a plus bx. This is nothing but the equation of the straight line. So here we can see linear regression goes from minus infinity to infinity. But in logistic regression, we want a probability which lies between 0 to 1. So we squeeze the line at infinity to 1. Similarly, minus infinity to 0. So that is how we'll be getting the sigmoid function. Here, if you see here, this is the equation of the sigmoid function. If we see here, equation of the sigmoid function is 1 by 1 plus e power of minus z. And here z is nothing but equation of the straight line, which is a plus bx. So we already know a equal to intercept and b equal to coefficient and x will act as an input. If I want to know if a person is studying for 10 hours or for 0 hours, so what could be my probability? So then I'll using this in place of x, like the values. And value of E is nothing but Euler's numbers, which is like 2.718. And P of I is nothing but probability of either pass or failure. Now you will be wondering like how to calculate these values of A and B. If we get here, for example, I'm just considering number of hours studied by a person is 0 hours. So if it is 0 hours, we definitely know like they're going to fail. There is no doubt in that. Correct? So I'm just assuming the values of A equals to 0 and B equals to 0 like the initial condition. So when I calculate this, 1 by 1 plus e power of minus a plus bx. So if I just substitute these values, 1 by 1 plus e power of minus a plus bx, everything gets 0. So e power of minus 0, which is nothing but 1, I'll just get 1 by 2, which is nothing at 0.5. So do you even think if a person is studying for 0 hours, like the probability of passing is 50%? How is this even possible? This is impossible. Like this is not at all correct. So what we will say, like the values of A and B need to get changed. That is how then the model will predict the correct values. If a person is not studying even for 1 hour, so if the person is studying for 0 hours, then it need to show that the person will fail. It shouldn't show the probability like 50% the person can pass. That is not at all correct. So we know like the value of A and B is wrong here. So to update the values, we will be using gradient descent. So gradient descent is nothing but A equals to A minus alpha into differentiation of loss function. Similarly, B also nothing but B minus alpha into differentiation of loss function in terms of B. Alpha is the learning rate here. So we already know like in linear regression, we know we will be having a best fit line, correct? So best fit line, which is nothing but where the error is less. So if my predicted point is this one and if my original point is this one, I'll be calculating this distance. I want the distance should be as minimum as possible. That is how I'll get this best fit line. Similarly, in logistic regression, we will be calculating this loss function. This loss function should be as minimum as possible. That is how I'll get the correct values of A and B for my particular data. So that is how initially I will take the values of A equals to 0 and B equals to 0. I'll calculate this loss function and then I'll be updating these values A and B continuously. So once if I get the updated values, I'll be using those values in my calculation. I'm just explaining you here like how we will be calculating these things, because this entire loss function and gradient descent function is like continuous repetitive task until you get the correct values. So here I have calculated the values of A and B using the Python script. As you can see here, in the input data for X, I just represented the number of hours, and for Y, it is a representation of either pass or fail. And we have integrated these values into the logistic regression model, and I have got the value of A as minus 3.74 as well as the value of B as 1.04. Now let's go back to our notes. So I have noted down the values of A equals to minus 3.7 and B equals to 1. So I just want to calculate if the person is studying for 10 hours, so what could be the result? What is the probability of passing or failing? So you know the equation of the sigmoid function is nothing but 1 by 1 plus e power of minus a plus b x. And I just represented a as minus 3.7 and b as 1.0 into 10, which is nothing but 10 minus 3.7. So I got 6.3. After doing this particular calculation, I got 0.99. So if a person is studying for 10 hours, it is representing that he is going to pass the exam with the 99% probability. Which means I can tell him like he is going to classify as 1, as pass. So that's all about this video. If you found this helpful, hit that like button, subscribe for more content and share it with your friends. Thank you.